Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have 1 minus k divided by k minus 1 is equals to 2, and we solve this problem for all the values of k. So here first we need to find all the roots of this equation, and at the last we will be verify that which of the roots are solution and which of the roots are extraneous root. Further, we solve this problem for two methods. I hope so you like both of these two methods, but if you have any other method in your mind, so please don't hesitate to write this method into the comment section. And now we move toward the solution of this problem from first method. In the first method here, we move k minus 1 from left hand side to the right hand side, and it will be written as 1 minus k is equals to 2 times of k minus 1. So here in the next step we have in the left hand side is 1 minus k is equals to, here we multiply 2 on both of these two values and it will becomes 2k minus 2. And further in the next step we move the variable terms into the right hand side and we move the constant terms into the left hand side. This means that we move this minus k to the right hand side and we move this minus 2 to the left hand side. So this will be written as, this is minus 2 becomes here plus 2 equals to, this is minus k. When we move it into the right hand side, it will becomes plus k. Okay. So further in the next step, we need to add or subtract the like terms, and we have, this is 1 plus 2 becomes 3 is equals to 2k plus k becomes here 3k. And here for the values of k, we need to remove this 3 from right hand side, and for this we divide both of the sides by 3. And when we divide each of these terms by 3, it will become here 3 divided by 3 is equals to 3k is divided by 3. This 3 and this 3 are gone, and we get here 1 is equals to, this 3 and this 3 are also gone, and we get here k. This is the value of k which we get here in the first method. And now in the next step, we need to verify that is this value of k be the solution, or is this value of k be the extraneous root. So for verification of this value, we need to copy down given question statement. Here it is 1 minus k divided by k minus 1 is equals to 2. And here we substitute the above value of k on both into the left hand side, and we check its behavior. And you see here this will becomes 1 minus 1 divided by 1 minus 1 is equals to 2. So further you see here in the left hand side we will get 1 minus 1 becomes 0 divided by 0 is equals to 2. You see here our left hand side becomes 0 over 0 form, and it is usually called that it is the indeterminate form, or in other words we say that it is undefined. Okay. So if our left hand side is undefined, this means that both of the sides are not equal, and if both of the sides are not equal, this concludes about that the value k is equals to 1 is not satisfied our given question statement. So we call that k is equals to 1 be the extraneous root of the given equation, and we will write here this is the extraneous root. And further you see here we cannot get any other value of k which is satisfied our given question statement. And further here we cannot get any value of k which is satisfied our given question statement, so we call that this question has no solution in general. So this is our final answer which we get here from first method. And now here in the next step we again solve this problem for second method. So for second method we need to copy down given question statement here, and our given question statement is 1 minus k divided by k minus 1 is equals to 2. So here in the second method, uh, here we just directly concludes about the solution set of this problem, and here we need to take common negative sign from numerator. So when we take common negative sign from here, we get the remaining values are k minus 1 divided by k minus 1 is equals to 2. And further you see here this k minus 1 is cancelled out by this k minus 1, and we get here minus 1 is equals to 2. So you see here minus 1 is equals to 2 is not possible because the negative term is equals to 2, and these are not equal each other. So we finally concludes about that here we cannot get any value of k which is satisfied our given question statement. So we finally concludes about that this question has no solution in general. So this is our final answer of this question, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.